Thank you. Okay, so hello. My name is Ilinca Pastia. I'm a first-year student at an aerospace engineering course at the University of Manchester, and today I'm going to present my PowerPoint about the Powerstation for the Habitat Marte mission 66. Okay, so. Um, there are the main points that I have to I will have in my presentation, like the internal design, machines technology necessary for the operational installation, possible resources to generate in situ or transporting from Earth, organizational structure, position, profiles and duties, astronaut training programs, YouTube videos to train astronauts, resources needed for 1 week, guidelines to be provided to other facilities and air station, specific protocols, routines of my facility, protocols of safety, protocol of occupancy, entertainment, protocols for food microproduction, protocols for 3D printing, technologies and outputs that could be applied to Earth, guidelines to be applied to daily life on Earth, and impacts to sustainable development goals, and also some other references. Okay, so for the internal design, so as an external view, I got a sketch from Mission 47, a model proposed by Ash Ratted, who made then the Powerstation presentation. He outlined the Powerstation and as energy resources, I mean, energy main power producers, he pointed solar farm, aeolic park, a kilopower energy plant, and also the MOXIE. Excepting for this, in my situation, I would put some like indoor produced power in the power station, but I will present it how I design it and where and how I'm going to manage it later on the presentation. As a how my station should look, there's also also this model was suggested by Ash in the same mission, but I got also the inspiration, or let's say also I got to adapt the model also from the presentation of my colleague Sylvester, who made about the engineering station, and also to put one level from the 3 levels that are required for my station to put underground. The others 2 are over the level of the ground. So like the ground level would be actually the second level, only the main area. Like there should be the dormitory, the toilets, the resting room, the kitchen, the training room. In the 3rd level, I opted for the laboratory communications, but the communication meaning like the panels to be able to chat with the others to the other stations. And I suggested in my case of my design to have actually 2 power monitoring area, one for the searching purpose, but also to be used as an additional in case that the main one is going to have any issues, that it's supposed to be on the 1st level underground level with the battery storage and the power monitoring. Okay, so at the 1st level, meaning on the underground, there's 2 upper levels. The battery storage area is big because the battery storage system can be divided into direct storage and indirect storage, and the direct storage to electrical, magnetical, and the indirect storage to artificial reservoir, natural reservoir. And the other parts, like somehow equal, are going to be the power monitoring and the power control and operational areas. And the second level, as I said, is the main area, the one that is connecting, is going to be the entrance to facility. There are going to be the dormitory, the toilets, the stairs to other levels. The common area also is going to be the dining area in order to optimize space, because the idea of this station is to have just an 8 diameter surface for each level. So each meter square is essential. Also, there's a kitchen storage room, and here is going to be a special isolation door, because I'm going in my design to put an air access to outside, in order to be able to go to the generator energy, to the energy generators. Maybe if there are issues or for the maintenance, it's going to be easier to access it from here, not to go to the main site and after that try to get outside. Also, I here start the vertical gardening to appear. Somehow, plants in kitchen helps improvise the atmosphere and the room temperature and other stuff. And in the gym facility and relaxation area, the vertical gardening will have most for the physical impact on the astronauts, but also due to the fact that here is going to be, they are going to do exercises, plants are going to benefit from their dioxide carbon, and they are going to grow in a better way. This is somehow adapted from the proposed main area level model by Ila, my colleague from this from this mission. So this is our just ideas of how it's supposed to look like the dormitory, how it's supposed to be inside of the toilet, the gym training, and also somehow an idea of how the vertical gardening should look like. As for the third level, there are the stairs to lower levels, the communication, the second power monitoring era, and also here's the large space for laboratory for research and development and maintenance of new devices. Well, the vertical gardening is going to be on like a half also here, but on the other half, there's going to be the photobioreactor, because I'm in my facility, I'm going to use a photobioreactor in order to be able to create biofuel. Somehow it's a new type of energy, but it's processing, it's somehow growing these days. It's a way of developing. Okay, so for the applied technologies, this is the second part, the machines, technologies necessary for the operation of the installation. So the machines can be considered the components and devices from the power station, like supporting technology for operational procedures, data collection, detection of failure, balance of energy, protective measurements. And also, we can say the machinery is the one who monitor like the power statics, quality of energy, detection of issues like faults, overload voltage, energy fluctuation, or other electrical problems. And as equipment, we can say that we have the battery, the circuit breakers, the transformers, converters, cables for electrical transport of energy like copper or aluminum, or even an alloy between them. As the technology, we can consider the power generators itself. So I choose like for 5 main types of generators, but they're going actually to be more detailed. The first one is the solar power generator. And it can be divided into 2 categories: a space-based solar power and a centralized solar power. Further differences between them, I'm going to say after this slide. The second type of power generator would be the wind power generator, like the wind turbines. The third one will be MOXIE, the fourth one will be nuclear power, and the sixth one will be I call them like alternative indoor produced power, like the biofuel, electromagnetic floor, or honeycomb. Okay, so going first for the solar power generators. The space-based solar power is using the prototype of geosatellites. It's designed for the low orbit but the thing is it's not on the ground level of the Mars, and it's on the name in space. This is somehow possible to help in producing the solar energy due to the fact that the atmosphere of planet Mars is somehow thin, and it's somehow the pressure is lower than on Earth. So this equipment is not going to be that affected if it would be on Earth. The centralized solar power is using receiver tunnels with solar panels acting as mirrors. So instead of just using the solar panels and putting them into rows, so instead of doing just that and actually trying to get the energy from that, we are going to directly centralize this energy by using the method of the centralized solar power. When the tunnel will receive all the light reflecting from the solar panels acting like mirrors, and is going to store the energy. Okay. Going deeply into the space-based solar power, this is an image explained from ESA, how the space-based solar power should act. Like, firstly, to get the solar radiation, after that, to focus on just this type of receiver. The receiver is going after that to transform the solar radiation into microwaves, and the waves are going to be directed to a tower or a special place on the ground, where after that microwave is going to be transformed into electricity. So it's like making electromagneticity just to electricity. And the two images above are just a way of showing how exactly it should work on space. And two panels that should attract the light, as I said, should be like the solar panels, like the one used also on the ground, but also it could be like a big mirror, big concave mirror. The difference will be in the way of manufacturing and maybe the cost and the resources. As for the centralized solar power, sandust storms are a problem because we are coming to a level where actually there is wind. The wind on Mars is due to the pressure, the atmospheric pressure on Mars, due to the levels of the ground from the Mars. But the idea is that there are actually valuable like number for winds on Mars. Like it could come from 12 kilometers per hour to up to 30 kilometers per hour, depends on the season. Mostly on the autumn season in Mars, they are the greatest wind speeds. So in order to be sure that also the centralized solar power will be efficient, we have the cleaning robots used to prevent deposit of dust, and they just use the air system. They don't need water in order to clean the solar panel. And in some cases, in order not to be necessarily like every time panel damages, the technician or sometimes somebody specialized in repairing it to go there and try to figure it out which one it is and how to repair it. There's developed a type of polymer coating for auto-generation that captures the sense, and at the micromolecule level, actually it helps the panel to rebuild itself again. So there should be no that much problem in the maintenance of a large scale of solar panels or large area of solar panels. Going to another type of energy power, that are the wind turbines. I will propose for my power station to have an equal distribution between the horizontal axis wind turbine and the vertical axis wind turbine. The vertical axis wind turbine will be more aerodynamically and will be more helpful in not having to control it so much remotely, like trying to find the perfect position in order to capture the wind. Also, all the data and all the components that are to be verified and secure that they are working properly are actually at the ground level. So you don't have to go up to the engine in order to verify what's problem with the vertical axis wind turbine. The only problem will be that it somehow be feasible and big enough to consider also the horizontal axis wind turbine, because it isn't as efficient as the horizontal axis wind turbine in capturing energy. So I think it should be like 70% or maybe less of a horizontal axis wind turbine energy will be actually the vertical axis wind turbine. So it will be almost half, and that's on a place like Mars, you need any amount of energy you can obtain. The third model would be the Marx oxygen issue experiment. It is based on the way it is based on the fact that the atmosphere on Mars is 96% of dioxide carbon, which in this process of MOXIE is going to use electrolytes in order to get oxygen. So you get the power actually like heat, but also you got oxygen in order to breathe. So it's very reasonable for the facility, all the facility, not just the power station. The nuclear power, supposed to be kilopower, is somehow dangerous because it works with uranium, but as an experiment on March 2018, this time done by NASA, showed that actually the kilopower would be very beneficial for lands like Moon or Mars in order to get energy. Then it's proposed to also be used in this power station and in this habitat. This highlight, there are three are the three indoor electricity producers. So the biofuel, who's actually producing in the photobioreactor process. So basically, is like cultivating some types of algae that don't consume so much oxygen. Actually, they are consuming more dioxide carbon, and in specific process, they are turning into biofuel, which can be used as a source of energy. The electromagnetic floor is based on the fact that you step on a pad and stepping on it, it will transform. It will have like an electromagnetic signal that will produce kinetic energy, and that kinetic energy is going to be stored as energy in a battery. The honeycomb is somehow based on the solar panel, but the thing is, it's mostly used in type of architecture, because it could be put it like as a roof of the facility, somehow as a covering, because even if it is new that in Mars the radiations are very powerful, this honeycomb can resend back the over amount of not needed radiation, and also it can filter the amount of heat that can get into inside. So actually this honeycomb is very useful for filtering the radiations and the heatings, and also the amount of solar light that goes through it. It will have more the plants, and that's why one of the reasons that I chose for the laboratory the plants to be on the third level, like on the higher one, in the higher level possible. Mostly because of the honeycomb that could be used for like a suitable place for plants. Going to possible resources to generate in situ or to be transported from Earth. From Earth, you need the components of the different types of power producers, because in situ, the energy is obtained using the Mars environment. The beautiful thing about the energy and the power is that if you have the specific components or devices in order to create it, you can make it from any place you are in. So like actually getting the energy is actually Martian energy. Okay, so after I'm finishing with the internal design, the technologies, and in situ or Earth, the producing of energy, I'm going to rely on the organizational structure. So I'm thinking about my power station to have 5 people. One to be the power station chief, one to be an engineer assistant, one to be a researcher, and actually to be 2 technicians, technician 1 and technician 2. The power station chief keeps contact with other chiefs, assure of the successful and correct operation of the station. He is the main responsible for the coordination of tasks, the management of system, the resource management, and also he's the one who's making the decisions, mostly in emergency situations. The engineering assistant is the substitute of the chief. Somehow it assures that the successful operation of specific sectors in stations are happening. He also develops the operational plans, designs and establishes the operational plans, also the procedures, and also defines and applies security procedures. the two technicians have like the same profile. I mean the same duties. Like they have to maintain and repair the equipment if it's needed. They need to supervise the correct operation of the system. They need to necessary equipment. They need a necessary equipment prepared, like how to make sure that the specific system is well equipped in order not to have any defaults, and also help the researcher or the other technician in case of needed. I thought like they should focus on different type of generators, like to be specialized in different type of generation. So for example, if the technician one is specialized in the solar panel, the technician two can be in the wind turbines. So the technician one can go for also for the nuclear power, and the technician two can go for the MOXIE. So they can divide their power generators. The idea is that if there are two, then the tasks are not going to be so difficult for just one person. And the researcher is going to develop and study the new methods of energy, develop types of new equipment, study and design of new equipment. So basically, he's going to monitor, make a lot of reports, and also conduct a lot of experiments. Coming from the astronaut training program, there's a basic general training, like to be able to sustain human presence in space, to overcome emergency, but general emergencies, like if somebody's having a stroke or something like that. You never know, but the idea is you have the overcome emergency training. You also need to know how to maintain a facility, practice to reduce costs and technical risks in overall. Training for the meet for crew decision making. Also, sometimes it helps to have a training for how to make the daily report, because you may need to underline some details that are needed for the entire research on the habitat. Also, the training, like daily workout in order to maintain their health, and handling isolation for long term, because if there will be a scenario when actually is going to be a disease or something that is viral, then they need to be psychically prepared for a long period when they cannot make contact with the others except from the ones from their station. And also there is the advanced specific facility training. You practice to reduce cost and technical risks, but this is like for specific positions. Depends, like the researcher knows how to deal with experiments in order to don't have not to be exposed to risks. The two technicians know how to troubleshoot the situation if they have a problem with a cable, with a generator, with a battery storage, or if they see that there is a problem with one of the power generators, they firstly try to see the problem, and after that to really overcome and resolve it. Also, there are the specific details on reports depending on the person's position in facility. Overcome specific like electrical shock emergencies, because if you are in a power station, there might be some cases when you are actually having electrical shocks, even if you don't want to. And not all of the astronauts are provided with this, because not all of them are working in the power station. And also, like the best training for the specific facility, this time the power station will be a simulation. of really working before actually going into. Some YouTube videos to train astronauts, like for basic understanding, will be for solar power chapter and for wind turbines. Like solar ore is actually the name of the prototype somehow for the protection of the solar panels. And if the astronauts are going to train, we also have to consider the, as I said, the scenario for isolation. In the scenario of isolation, you need to think how they are going to survive. And one of the best one of the best way of thinking about is to do like a plan for resources needed for a week and actually apply for it, because also the amount of resources like the food or water are limited in a space like Mars. So for one person, the consumption per day will be like you need the 3 meals per day. It's like the morning, in the breakfast, the lunch and dinner. All of them are important in order for the organism to work very well. That will be in total like 2,100 grams. Also, water for drinking. I said like for an approximation 2.5 liters, because if it's about a woman, then she might not need like really 2.5. She can just drink 2. But if it's a man, he will need like 3 liters. So making the assumption for 2.5 is just between. Consumption for a week, then 5 days, is just multiplying by 5. So I get like 10,500 grams for food and 12.5 liters of water just for drinking. And that's just one consumption. I mean, 1 week consumption for one person. For 5 person, it will be like for 1 week, for that 5 days, the amount of food consumed will be 52,500 grams. And also the amount of water for drinking, it's 62.5 liters. It also has to be considered that even if I'm making the resources needed, like the basic, because we need the food and water, there are also going to be other needs in order to stay and do your daily routine. So are not considered the toilet who recycles its own water. But for example, if we want water consumption for daily routine, like washing the dishes or making a shower, multiplied for 5 days, on Earth, actually, a person consumes like 100 liters of water for just 1 day. So it will be somehow harsh, because there is not that much amount of water, but still it can be dealt with it. But the idea is the water consumption for daily routine can really need to be considered. And also the water is needed for the plants. Like a plant in a pot consumes in 1 week 0.5 liters of water, but at the room temperature of like 20 Celsius degrees. And this also depends on the amount of sun she needs. And also other resources now, a comfortable temperature inside the station for both habitants and vegetation is needed. Going from the resources for a week and training, Now I'm going to speak about the guidelines to be provided to other facilities or the whole station. So the whole station has to be sure that they monitorize the energy consumption, avoid overuses of energy, if it's not reasonable that overusage. Also, they need to report any electrical and power related issue. So this is also, this is applied like for the entire Habitat Marte. For the engineer station specifically, is the usage of a specific amount of energy for exploration devices and experiments, like they all have the rovers or drones who need to explore, or they and they need fuel in order devices to work. The greenhouse, they need a supply of energy for plant growth and experiments on the plant growth. The sanitation and health station should report weekly the situation of every electrical devices, because the sanitation really works on how every device on the sanitation, like purifying the water or the air, needs the energy, electrical energy, in order to properly function. And the health station, for example, scanning or handling or being able to use the data about somebody's health is like a really important thing to be considered. The launchpad station needs the usage of specific amount of energy in order for the takeoffs, because if you want to go back, you you need like a lot of amounts of fuel, and that needs to be stated in order maybe to make sure that for how many days the energy is going to be stored in a specific place in the battery storage, in order after that to be applied for the specific vehicle who's going to take off. Going to protocols, like specific protocols of the facility, we have to take into consideration the life support systems and environmental control. So you have the region Powerstation, and after that you are trying to section the generator and components from other components in order to avoid the widespread, and also to section the issue component from if it's risky for plants and habitats. You have to make sure that everyone is safe from it in order to avoid life risk. Also, you have to start the process of checking the stats of all components and protection equipment. You have deactivate and now you reactivate after fixing the issue of the backup batteries and all stuff. If there is a need of more time to repair the problem, then the alternative ways of producing the energies can be considered, or the backup batteries they have enough energy stored. Like the alternate ways of producing the energy actually are the indoor energies that maybe the honeycomb cannot be assured that, for example, the battery is the problem, because if there's no energy stored there, then the honeycomb cannot use its energy. It can just be used as a filter. But for example, if I'm using the electromagnetic floor or the biofuel, that are really going to help me to have somehow still the energy enough in order to make sure that the sanitation program is working, like in order the water to be potable, and also the oxygen to be produced, and to be sure that nobody's going to be affected, and the life needs are short. So the system recovery is actually like a treatment after the decoupling, and during the process I described before, you have to assess pesticide, you make the inventory of losses, you recover schedule, you make a recovery schedule in order somehow, after some weeks, to make sure that everything should go normal as before. And also you still need to keep the maintenance of the system. There is a protocol also for occupancy or entertainment. So the astronauts don't just need to work, they also need social interaction or relaxation areas. Plans that have a good physical impact on astronauts are required on a, yeah, the landscape of Mars is somehow more desertic. So like the presence of a plant somehow affects in a positive way the psychological part of an astronaut. Also, the physical exercises are helping to maintain the health, and also to make sure sure that the astronaut is still on the it's still it's still in a good condition in order to maybe for some specific task they are required an amount of strength, and the physical exercises are assuring that he's having that amount of strength. Also, the multicultural promotion, like ideas, traditions, and somehow like a globalization idea, but in Habitat Marte, is something that makes people to be more open to speak about themselves, and that helps a lot, especially when you are in a small enclosed space. Because as I said in the beginning, the power station, it's having like 3 levels, and each surface area is like having diameter of, it's a circle with a diameter of 8 meters. Then will be like 50.26 meter squares for an entire level. It sounds like a reasonable number, but still, like when you are actually there in that surface or space, you see that it is small because you have so many things inside of it. There's also a protocol for food microproduction, even if it's about the power station, because each station needs to be sure that it can supply its own food in case of the isolation situation. There are 2 ways of obtaining the food. You either use the supplies from the storage room, the one that I put it in the kitchen, or you use the plants from your vertical garden. It is advisable to use your own production, like in proportion of 80%, as needed in isolation emergencies. And things to consider in growing the plants are like the weekly water consumption per plant, filtration of air and soil, and the room temperature. Also, the food logistics and waste management help the astronauts to be organized in production of food and to maintain their healthy routine of eating. the 3 meals per day. For the protocols for 3D printing, because 3D printing is actually really help or bonus these days, because you just need the, let's say, brute material, and actually using the 3D printers, you can create many things. So you don't need to bring them from Earth. You just create them on demand. If you need tools for working on troubleshooting, I will put it to YouTube videos like screwdrivers, or in order to find the length of some interesting shapes, are this type of tools are found in this video. Also, there's a specific 3D print for electrical circuits with using graphenes. So actually, it's like making a circuit, but in the variant of 3D printing. So again, you don't need to bring from Earth. You can make it here, just using the graphene. And also there are the components of visualization and protection, like for the cables of copper and aluminum, you need that polymeric protection. Spin-offs. Technologies and outputs that can be applied to Earth. So yeah, the experiment is supposed to be like on Mars. But that doesn't mean that also the technologies and researches from there cannot be used here on Earth. Actually, there are developed new types of environmental and eco-friendly energies. And these days, the industry really tries to put the accent on vertical axis wind turbines and solar panels. But also the horizontal axis wind turbines are used. And here is supposed to be representing the biofuel, that it is still using the natural resources, like, I mean, the biofuel, it's still coming from plants, and the plants are still considered to be from the natural resources like wood or coal that somehow are tried to be avoided. But in this manner, the microalgae that are actually developed in the biofuel process are not that harmful like the wood or coal pollution that comes after burning the resources. Guidelines to be applied to daily life on Earth, yeah, to avoid environmental damaging energy as much as possible as it affects the climate and life on Earth, and also to maintain and regular inspection of energy sources in order not to consume so much, because like a really major problem of most of the societies is that they consume more than they need. And also, in maintaining the energy sources, you have a long-lasting energy source, and not to have to make or buy the new one. It's still on reasoning with the amount of resources you are using to buy for the energy resource. Impacts to sustainable development goals, the outcome of Powerstation research, the first sites are like discovery of new source of green energy, non-polluting development of green energy, development of life support on other planets, obtaining better energy quality and bigger energy quantities by using low amounts of resources. Like the directly affected goals are the affordable and clean energy, the industry, innovation and infrastructure, responsible consumption and production, and climate action. But actually, if you came to think more about what the energy does after you produce it and how you are going to use it, they're actually indirectly affect the goals, like no poverty, because people will afford energy in order to help them in the daily life. So they would be somehow privileged to have the energy if it would be more affordable for them. Quality education, because there's the internet that somehow is related to the energy, because on computers and electrical energy, um, the internet is storing so much information that information can help a lot in achieving the own education. Also, when there's more energy, there doesn't work and economics growth in each sector, like in medicine, in engineering, in industry. And if the energy is going to be clean, like environment friendly, eco-friendly, also the life below water and on land is going to be safer. And in the end, there are the other references, like from the previous presentations for solar panels, wind turbines, biofuel, or normal daily consumption about water amount. Um, my personal contact and social media on LinkedIn. You can find me on this address, on by email by accessing ilinca.pastia@gmail.com. Thank you very much for your attention. Um, I hope you like my presentation.